So this is Unit 1, Part 2, Quantitative Chemistry. In this section, we're actually going to cover measurement, significant figures, dimensional analysis, and density. But for this video, we're going to focus on measurement and dimensional analysis. Now, what is a measurement? Well, it's a quantitative data that can be reported using units of measurement. Now, for chemistry, we're going to use the SI system. The SI system stands for Système International. I know I just butchered it, but in English it means International System of Measurements. And this is based on the metric system. And all of our measurements are based off of this system in chemistry. Here are the examples of base units of measurements that we will be using in science. Length is going to be read in meters, which is M for the symbol. Mass is kilograms, which is kg. Temperature is in Kelvin, not degrees Celsius, not Fahrenheit, and its symbol is K. Time is in seconds, not minutes, hours, and its symbol is S. Energy is recorded in joules, and that's a J, which is not calories. Frequency is per second, and it's written as Hz, or also known as hertz. The amount, and we will talk about amount, and it is represented by moles, and the symbol is MOL. And pressure is pascals, and it is PA. There are other ones that in science that we use. It's amperes for current, and candela for luminosity intensity. Now, one thing you guys will notice, we don't use pounds when we measure mass. It is actually, that's weight. And the biggest difference between mass and weight is weight depends on gravity. And that's the reason why if you were on Earth versus the moon versus Jupiter versus the sun, your mass may remain 63.5 kilograms at every single one of these planets or orbits, but because of gravity, your weight will actually change. Okay? And so if you notice in the sun, because of its great gravitational pull, your weight would be 3,914 pounds, which is almost 2 tons. So we measure in mass, which is a quantitative amount, while weight is based on gravity. Okay, so back to units of measurement and prefixes. So first and foremost, I really want to make sure you guys know what units are. And so these are base units: grams, liters, meters, and seconds. And I'm going to use a meter stick as my biggest example here. So here's my big 1 meter stick. Okay, from one end to the next, it measures 1 meter. But now let's go ahead and divide this meter stick into 100 equal parts. So now we have all these tick marks, 100 tick marks on our meter. Each tick mark represents 100th of a meter. And now we can replace this with a prefix in front of the meter. So we are now going to have this as centimeter. So each one of these marks now represents 1 centimeter. And so that means if you have 1 meter, you will have 100 centimeters for every meter. Now let's go ahead and instead of having it divided in 100 parts, let's talk about what happens if it's in 1,000 equal parts. Well, if you guys notice, there's even smaller tick marks on here. These represent 1,000 tick marks on our meter stick. Okay, there is now 1,000 tick marks, and each tick mark represents 1,000th of a meter. And we will replace it, instead of a centimeter, we will call it a millimeter. So for one whole entire meter, you have 1,000 millimeter marks. So what is the purpose of using these prefixes? Well, it's just basically to indicate if you have a smaller number or smaller measurement or a larger measurement. Because again, I've been talking about how a millimeter, there's 1,000 millimeters in 1 meter. But What if I think about kilometers? A kilometer now has 1,000 meters. So these prefixes help you just indicate smaller or larger measurements. And here are all the different prefixes that are used in the international system. Tera, giga, mega, kilo, centi, milli, micro, and for some reason this one shouldn't look like that. This actually should look like a squiggly M, and that is the Greek letter for mu. You have nano, pico, and femto. Those are our prefixes. And we will talk about how to do prefix conversions later in class. So from units, you can actually get derived units. That means you have more than one base unit. For example, volume is length times width times height. That means you're taking centimeter times centimeter times centimeter, and you can get centimeter cubed. And that is a derived unit because now you have more than one unit. Density is mass over volume. So there are two base units in our in density. So this is considered a derived unit. Okay, so here are some more examples of derived units for density, concentration, area, volume, speed, acceleration. So one thing you guys need to know is how to convert degrees Celsius, because majority of our instruments, our thermometers and our temperature probes, will have readings in degrees Celsius, and you need to know how to convert it to Kelvin. And it's very simple. So you need to take the degrees Celsius and add 273.15 to it, and you get your Kelvin temperature. Okay, and vice versa. If you're given Kelvin and you need to find out your degrees Celsius, instead of adding, you would take your Kelvin and temperature, subtract 273.15, and you'll get your degrees Celsius. Okay. Another thing I need you guys to know, you just need to memorize this. Put this in your head. 1 milliliter is the same thing as 1 centimeter cubed. Okay, if you've ever heard of the term cc on one of those medical shows, you might be watching like House or ER or Grey's Anatomy. Whenever they say, oh, administer 5 cc stat, well, the 5 cc stands for milliliters. Okay, cubic centimeters. So that's the same thing as milliliter. The other thing you need to memorize, but for just knowing it, is every 1 liter is the same thing as a decimeter cubed. Okay, and finally, you do need to know this equation: density is equal to mass over volume. And so now that we've covered what measurements are and how you can do a little bit of conversions with certain temperature probes that we have, or just terminologies that you need to know, let's go ahead and move forward to what is a dimensional analysis. So we're going to go ahead and learn dimensional analysis. This is also known as unit conversions. Now in your notes packet, you guys actually have it called inquiry activity, and I'm going to guide you through this inquiry activity. So please follow along. Okay, in part 1 of this activity, you guys are actually going to learn how to gather the equivalent statements from a word problem. Okay, so for example, it says here the gas station is currently selling gas at $2 per gallon. Okay, this sentence is actually a equivalent statement, but we need to figure out, how do I write this as if I were doing in math. And so this actually comes out being 1 gallon equals $2 because they are selling gas at $2 per gallon. So here are some extra examples. It says here, she walked 1 mile in 18 minutes. So she walked 1 mile, 18 minutes, and that is the equivalent statement I can write. Here it says there, a hamburger at McBurgers cost at $1.50. I can write 1 hamburger equals $1.50. Okay, and there are 500 sheets of paper in a ream of paper. 1 ream equals 500 sheets. Okay, I hope you guys are getting this. So, in this part, I want you to write 5 equivalent statements from the description above. So, it says here, during a car trip, the car traveled 90 miles away. The trip took 75 minutes to complete. According to the gauge, the car trip used up 3 gallons of gas. The driver took 1 stop for a bathroom break during the trip. He noticed that he played 28 songs by the end of the trip. So here's one of the equivalent statements I can write. 1 trip equals 90 miles. Okay? And it says here, another one I could write is 1 trip equals 75 minutes. Now you go ahead and write 3 more equivalent statements. Okay? You can pause here and then play again once you are ready. Now, after you've written all of your equivalent statements from the statement model above, we're going to write 3 more. Instead of 1 trip equals whatever, we're now going to start writing combinations. For example, okay, 90 miles equals 3 gallons of gas. Or 90 miles equals 1 bathroom break. Or 75 minutes equals 28 songs. Now, from what you have written, write 4 more relationships that does not include the ones I have here and the ones that say 1 trip equals. Create 4 more that you can obtain from the Model 1. And then pause here and play again when you are ready. Okay, now we're off to the part 2, writing conversion factors from these equivalent statements. Okay, if you notice in this, my equivalent statement is written as 1 mile equals 18 minutes. I can actually write it in 2 types of fractions. Okay, I can write either 1 mile divided by 18 minutes, or I can write 18 minutes divided by 1 mile. Okay, similarly for 1 hamburger equals $1.50, I can have 1 hamburger over $1.50, or I can put $1.50 divided by hamburger. And finally, 1 ream equals 500 sheets. I can have 1 ream on the top and 500 sheets on the bottom. I can have 500 sheets over 1 ream. Okay, so each conversion factor can be written, equivalent statement can be written in 2 conversion factors or 2 fractions. So now it's time for you to go ahead and pick some of the equivalent statements you wrote from part 1 and turn them into conversion factors. You can pause, write your conversion factors, and then move on. Now in part 3, we're going to actually now learn how to do the unit conversion, or also known as dimensional analysis. So in this model, if you notice, I have numbers, okay? I have 16 times 17 over 8 times 3 over 17, okay? You can simplify this by canceling out common numbers and then finally getting your answer. Now, what if instead of numbers, I have just units? So here's my days times hours over days times minutes over hours. Well, if you notice, days divided by days, they cancel each other out. It'll equal out to 1. Same thing with hours divided by hours. It'll still cancel each other out, and you get 1. So you end up, your units, if they all cancel out, you end up with minutes because that's what's left over. Okay? But now, what happens when you have numbers and units? So the first thing you do is you're going to actually look at the units. Okay? If you notice, days times hours over days times minutes over hour. I cancel out the day because 1 is on the top, 1 is on the bottom. Cancel out hours because an hour is on the top and an hour on the bottom. I'm left with minute. Okay? Now I'm going to go ahead and focus on the numbers. Okay, 2.5 times 24 over 1 times 60 over 1. I can't really cancel any numbers out because there's no common number. So what I end up doing is I actually multiply it out. 2.5 times 24 over 1 times 60 over 1. And that gives me 3,600. I get this minute for units because that is what the minute is left over. Now you get to practice one-step conversions, or two-step conversions and multi-step conversion. You guys will get to figure that out in the next few slides. Okay, so here is a one-step conversion. This problem asks us to convert 5.64 centimeters to inches. And I have given you the equivalent statement. 1 inch is equal to 2.54 centimeters. And I've also given you the two conversion factors. 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. Now, I have set up my dimensional analysis like it is in Model 3, in the picture above. Now, I have 5.64 centimeters, which we are starting with, and now I need to pick which equivalent statement properly goes in here. How do I cancel out centimeters? If you guys noticed in the model above, you need to have the unit centimeters in the bottom. So the correct answer, or correct conversion factor you should be using is this. So I would be putting 1 inch on the top and 2.54 centimeters on the bottom. And I actually cancel out my centimeters. Now when I do the math, I take 5.64 times 1 divided by 2.54 centimeters. And that equals 2.22. And since I'm left with only this unit, inch, my unit ends up with inch. So the final answer is 2.22 inches. In this two-step conversion, you're going to convert 5.64 centimeters to inches. Just like one step, I had this equivalent statement and the two conversion factors given to you. Here's my other equivalent statement. Now you have to write your own two conversion factors, and then you have to go ahead and solve and make sure you write the right conversion factor that goes into this spot and one that goes into this spot, and then get the correct answer. Pause here and do your work, and then unpause when you are ready to check your work. So you should end up with 222 inches, and this is the correct setup for your conversion factors. Okay. So now here's a multi-step conversion. Now you have to convert 2.1 weeks to seconds. I have written out your equivalents, the 4 equivalent statements that are needed for this problem. It's up to you to write the conversion factors for each, and then write in the correct conversion factor in each one of these, and write your final answer in the space to the right. Pause here, do your work, and then unpause to make sure you did the correct work. Here's your final answer. You should have 1,278,080 seconds as your final answer. These are all the equivalent statements you should have written, and this is also all of the correct conversion factors that go into those places. So now it's time for you to practice your unit conversions, okay? I have the problems all here, and then the equivalent statements needed for the problems. I will go ahead and let you guys work it out, and then I will only provide the final answers. I won't necessarily give you guys this the correct conversion factor. So if you're really having problems, come and see me on the next day at school. Finally, practice this page. I have given you all the conversion factors needed for all of the 5 problems on this page. And then also try this page. All the equivalent statements will be on the extra worksheet that I hand out to you. And now try it as best as you can. If you have trouble, then go ahead and ask in class when I see you next. And this is the end of this video. Good luck, and I shall see you in class. Thank you.